All right, so here we are wrapping up Chapter 5 with the second half of Section 5-6, dealing with solving systems of linear inequalities. In number 7, you'll notice that both of our linear inequalities are in slope-intercept form, so that is quite helpful. So let's go ahead and identify our important pieces of information with our first linear inequality. So with our y is less than or equal to negative 2x minus 4, our slope is negative 2 over 1, and our y-intercept is negative 4. Because it's a less than or equal to, it is a solid line shaded below. So let's go ahead to our graph and start plotting our important points. So we are going to begin with our b, so our y-intercept at negative 4. And we're going to rise negative 2, run 1. So down 2, right 1. Down 2, right 1. Down 2, right 1. You can also go up 2, left 1. Okay, so I like to plot as many points as I can. And we will graph with a solid line because of the or equal to. So here comes the solid line. Now remember our shading. It says y is less than or equal to, therefore we need to shade underneath our line. So here is our underneath shading, where in terms of this linear inequality, the boundary line is included in our solutions. Okay, so there is our first linear inequality for our system. Let's take a look at our second. The second linear inequality is y is greater than negative 2x plus 5. So you may look at that and be like, something seems familiar. Well, the slope of that linear inequality is also negative 2. And hopefully you remember that if two lines have the same slope, it means that they are parallel. Therefore, they will never intersect. So this is going to be a slightly unique situation. So our y-intercept is 5. Because it is greater than, this is going to be a dashed line and shaded above. So let's get out our plotting tools. So the y-intercept of positive 5, go up to 1, 2, 3, 4, 5 on the y-axis, and rise negative 2, run 1. So down 2, right 1, down 2, right 1. Okay. And up to left 1 also works. All right, so I've got to draw my dashed line through these points. It does continue on in both directions, and if we're shading above in terms of this y-intercept is this top right region. So let's think about this for a second. Now let's keep in mind from yesterday's video, or from the first half of this lesson, that our solution region is where we have both types of shading. Well, in number 7 here, we don't have any area on this particular coordinate plane where I have both the blue and the green. So there are no ordered pairs that satisfy both linear inequalities. So this particular system of linear inequalities is no solution. Okay, we have no overlap shaded region. Okay, so when we run into parallel lines, you've got to be careful. Let's take a look at number 8. Very similar circumstance, but let's see how this transpires. So the first linear inequality, our y is less than 3x plus 6, has a slope of 3 over 1 and a y-intercept, a b, of 6. Because it is less than, it is a dashed line, and we shade below. So we go to the y-axis at positive 6. 1, 2, 3, 4, 5, 6. Plot the point, and now we rise 3, run 1. I'm out of space, so now I'm going to go down 3, left 1, down 3, left 1, down 3, left 1. Especially with my dash lines, I need to have as many points as I can so that I know how to draw my line as nicely as possible. So here comes my dashed line. And shading underneath means we are down in this region. For our second linear inequality, oops, so that's our first. For the second one, we have y is greater than 3x minus 2, giving us a slope of 3 over 1, same as the previous one. So we have parallel lines again, and a y-intercept of negative 2. Because it is a greater than, it means we have a dashed line, and we're shading above. So getting our plotting tools out, we go down to negative 2 on the y-axis, and we rise 3, run 1. Rise 3, run 1. Rise 3, run 1. Keep plotting those points. Could also go down 3, left 1. All right, so we need to fill in with a dashed line. And we are shading for the second linear inequality above that. So that means above it is going to be this whole region. So now when we look at this situation, unlike the previous, the space or the little canal between our two linear inequalities, it was completely open. In this particular case, between our two linear inequalities is where I have that overlapped region. Okay, so our solutions lie in this little canal between our two linear inequalities. Okay, so I'm going to label that as my solution region, just to make it clear. The boundary lines on the top and bottom, neither of those lines contain solutions because they're both dashed. So if we remember, we are supposed to list ordered pairs that are solutions and ordered pairs that are not. So two ordered pairs that are solutions, I've got 0, 0 is in our solution region. And let's go negative 1, negative 1. So not solutions would be any ordered pair or ordered pairs in just the blue or just the green. So let's go 5, 5 is blue only. And negative 5, 3 is just green. And we'll do one more of this type. Number 9. Our first linear inequality says y is greater than or equal to 4x minus 5. That gives us a slope of positive 4 and a y-intercept of negative 5. Because it is greater than or equal to, that means it is a solid line shaded above. So getting our plotting tools ready. Begin with the b at negative 5 on the y. And rise 4, run 1. Rise 4, run 1. Rise 4, run 1. Also go down 4, left 1. We have a solid line. That does continue forever in both directions. So there is inequality 1, and we are shaded above, which would be this piece. Once again, we've got another system here where our second linear inequality is parallel to the first. We've got that same slope again. So our two lines will not intersect, so this answer will just potentially look a little funny. So y is greater than or equal to 4x plus 6. Our slope is 4 over 1. And our y-intercept is positive 6. Because it is a greater than or equal to, it is a solid line shaded above. So we're going to begin with our b, the y-intercept of positive 6. 1, 2, 3, 4, 5, 6. And rise 4, run 1. Or down 4, left 1. Okay, so we've got another solid line here for this boundary. So we will draw that with, you should be using your straight edges at home. This boundary line continues forever in both directions. That is number 2. And we're going to shade above that one as well, so I'm shading up here. So this one's actually kind of cool. We do have a region where we have both the blue and the green, and that region is also the same region that represents all of the solutions for our linear inequality number 2. Okay, because this green, all of this green shaded region fell on top of the blue. So if I color in red, you will see that this whole solution region is also just every possible solution for our second linear inequality of our system. Okay, so that's kind of unique as well. Okay, So we want to make note of that. So first, let's list two ordered pairs that are solutions, two ordered pairs that are not solutions, and then we will write about that other note. So solutions. Ordered pair that is a solution, let's go -5, 0, right there on the x-axis. And -10, 3. Not solutions. Would be 0, 0. The origin is only blue. And let's go 10, 1. That has nothing. Okay, so let's also, as I said, add our note here that the solution to the system, okay, is equivalent to the solution for, the whole solution region for the second linear inequality. Solution to system is equivalent to all solutions for linear inequality number 2, which is the y is greater than or equal to 4x plus 6. So all of those solutions for that second linear inequality represent solutions to the whole system, or solutions to system are equivalent to all solutions for linear inequality number 2. Okay, so the little canal in between here does not include solutions, only this top left portion. All right, so we are going to move past numbers 10 and 11 and wrap up with our word problem. So the word problem says, at her party, Alice is serving pepper jack cheese and cheddar cheese. Okay, so we've got two different types of cheeses. She wants to have at least 2 pounds of each. Let me flip my screen around here so I can do things neatly. So she wants to have at least 2 pounds of each. And she wants to spend at most $20 on cheese. Now there's some information in the table here regarding the prices. So we want to show and describe all possible combinations of the 2 cheeses Alice could buy. List 2 possible combinations. So this is a situation where we've got quantity and we've got money involved. Okay, and we have 2 different types of cheeses. So let's say pepper jack was first. So we'll have let X equal pounds of pepper jack and Y equal pounds of cheddar. Now, in terms of the quantity equations, and it's not equations, it's technically inequalities, in terms of the quantity, she wants to have at least 2 pounds of each. So up until this point, we've only ever had 2 equations or 2 inequalities for our systems. But here, we're actually going to have 3. Because if I want to say she needs at least 2 pounds of pepper jack, it means X needs to be greater than or equal to 2. 2 or more. And if she needs at least 2 pounds of cheddar, it would mean Y needs to be greater than or equal to 2. So these two deal with our quantity, the number portion, whereas now we need to talk money. Pepper jack is $4 per pound, so we're going to put the 4 with the X, so 4X. Cheddar is $2 per pound, so plus 2Y. And she wants to spend at most $20 on cheese, so no more than 20. So that would mean less than or equal to 20. So that's going to be our money inequality. So this particular system is the first one that has 3 inequalities. But that's okay. We just have to find where all 3 regions overlap. So let's go to our axes and label. So X was pounds of pepper jack cheese. So this is pepper jack, and the unit is pounds. Y was cheddar. And that's also in pounds. And this is talking about cheese for a party, I guess. So cheeses for party. All right, so we've got 2 special lines here. Thinking back to, I think it was chapter 4, when we talked about X equals a number and Y equals a number in terms of graphically. The X equals was a vertical line. Okay, so the first one is going to be a vertical line through X equals 2. Now, because it says X is greater than or equal to, let's first draw this line. It is going to be a solid line, so I'm going to go to my X value of 2 and graph that. It's not perfect, but good enough. And if it's X is greater than, X is getting bigger to the right. Okay, so instead of above, below, X's get bigger to the right. So let's try to shade relatively neatly. Okay, so this whole region is going to be, I'm going to do it in purple. I guess the next one I'll have to use a different color. I'll use pink. And the money one I'll do in green. And see what kind of lovely color mixtures we come up with. So if I'm talking now about Y is greater than or equal to 2, well, if the X equals a number equation corresponds to a vertical line, a Y equals a number would be a horizontal line. So Y is greater than or equal to 2 is going to be a horizontal line through Y equals 2. And because it's or equal to, it will be a solid line. And that solid line will then be shaded above because Y is getting bigger above. So here's my Y value of 2. Boom. Okay. So we'll get our shading. So this one we are going above. Okay, so at this point, where we have both types of shading is a nice little rectangle over here, right here. Okay, so where our purple line is on the left, our pink line is on the bottom. Now we need to take into consideration our money inequality. We can graph this however we want. Let's use green. This is going to be, it's going to have a slope, so it's not going to be just a straight vertical or a horizontal line. So let's get Y alone. We'll practice that. So we'll subtract 4x. So we have 2y is less than or equal to negative 4x plus 20. And then when we divide both sides by 2, we divide everything by 2, giving us y is less than or equal to negative 2x plus 10. So our slope is negative 2 over 1, and our y-intercept is 10. So let's get our plotting tools. Our y-intercept is positive 10, all the way up here. Now our slope is negative 2 over 1, so down 2, right 1, down 2, right 1, down 2, right 1, down 2, right 1, down 2, right 1. This is an or equal to, therefore it's going to be a solid line, and we're going to shade below. So if I get my solid line out, this would also be a good linear inequality to graph using intercepts, because that works nicely. So solid shaded below is now going to take us underneath that green line. So now the question is, where do we have all three colors shaded? Well, this graph didn't turn out too ugly. It's going to be in this little triangular region. Okay, so let's... Come on. All right, so let's label that our solutions are here. Turning my computer around. Okay, so let's list a couple combinations of the cheese options that she can purchase. So let's say 3 pounds of pepper jack, 3 pounds of cheddar. So what's this person's name? Alice. So Alice could serve, or could buy 3 pounds of pepper jack, I'm just going to call it PJ, and 3 pounds of cheddar. She could also buy, we could do 4 pounds of pepper jack and 2 pounds of cheddar, because that ordered pair occurs on the boundary lines, and those boundary lines are solid. Okay, so 4 pounds of pepper jack and 2 pounds, of cheddar. Okay, any combination in the triangular region or on the left purple boundary, bottom pink boundary, or technically the hypotenuse, the green boundary, okay, would be acceptable.